In this example, we're going to look at a pass by reference as opposed to a pass by value, which is what you've been doing all along. Let's start with the pass by value, and then we'll move into the pass by reference. So this first thing we do will really be nothing new to you. Why don't we create a simple function that will accept a value like a number 3 or a number 5 and then square that value and give back the perfect square like 9 or 25 respectively. So let's set up our function declaration here. Again, we're getting back a perfect square, which will be an integer. So the return type there is integer. Why don't we call our function square this, and it will accept an integer for an argument. So there's our declaration. Let's write the definition. Why don't we just name our parameter I? And you know what we'll do is maybe square I and then overwrite the original value of I, and then we'll return that. Okay, so here, I comes in, let's say it's number 3, and 3 times 3 is 9, and that 9 is going to be placed into I. So now the original 3 there has been overwritten. We'll return the 9 back to main here. So let's get a number from the user, and then we'll pass that to the function and square it. So I think what I'll do is I'm going to call this variable in main original I. That will be helpful later when we talk about a pass by reference. And we'll say enter an int. And then we will put that int into original I. And then why don't we just display the answer to the user? You may be tempted to call the function like this, but remember, when you get a value back from a function, that function call is going to be part of a larger statement. You're not going to see the function call hanging out on the line by itself like we do here. That worked when we were working with functions that had return type of void, but this won't work. I mean, it will work. The program will run, but it'll be completely useless. We'll get the value back, our 9 or 25, whatever it is, but because we're not doing anything with it, we're not putting it into a variable, we're not putting it into output stream, it just kind of goes nowhere. So again, when you have a function that gives you something back, like this one, the call to that function is not going to look like this, like it's just the only thing on the line. It's going to be part of a bigger line. So I think what I'll do is just throw it into the output stream, like this. We'll maybe make a little sentence out of it. Okay. And that should do it. Okay, so I'll enter a 4. I get 16 back. It's working. Let me just step through this really quickly, just so you can see what's going on behind the scenes. I'll enter a 5 this time. Okay, and let's see. So the original I has a value of 5. And here I am at my breakpoint. I will press F11. Okay, here we are at the front door of the function. Look who's coming through the door. The 5 that I entered. The 5 will be squared, and we'll get 25. Okay, now I is 25, and that's what's going back to main. Okay, so I just want to prove a point here. Then we'll switch to the pass by reference, which is actually what this is about. I want to display the value of the original I, the one that is created here in main. Remember what I said. This original I is not the same as this guy. These are two separate variables. A parameter is like a private variable that belongs to the function only, and the function uses the values that are passed into the parameter. So these are different variables here. So let's see. We're going to print the value of original I after all is said and done. Okay, so let's try number 3 this time. Okay, 3 squared is 9, and then the original I remains at 3. Okay, what we mean by this is a pass by value. is a pass-by value, meaning when we're passing this argument here, we are passing the value within the original I variable. We're not passing the variable itself. Really, you can't pass variables. Variables are fixed in memory. They don't move, okay? But you are passing the value that is in the variable, the number 3, the number 5, the number 4, whatever it is. You're making a copy of that and passing it down to the function, but the original remains untouched. And that is why when I ran this, the original value was preserved. It was untouched. We had a 2 in there. We made a nice copy of it. We passed the copy to the variable. It gave us back a 4, but that original 2 was untouched. Okay? So that's a pass-by value, which is the way we've been doing it all along, which is the default. There's also this thing called pass-by reference. And you really only want to use this when you really know what you're doing. By most of the time, in fact, I'd say 95% of the time or 99% of the time, certainly in this class, the pass-by value is what you want to use. But there are times when you want to pass by reference. And for example, if you're passing a very large thing, like a large struct, then you may want to pass by reference because when you create that copy in memory, it takes up memory. So one reason is to preserve memory if you want to not have to do that copy. So let's do a pass by reference. And really, passing by reference is just like a pass by value syntactically, except there's one difference. And that is when you put this guy in the ampersand, you put it in the function declaration, and then down here again in the function definition. Okay? Do you see, though, I just made 2 very small changes to this program. Ampersand here, ampersand here. Okay? We have now changed this to a pass by reference, and let's look at the result. Okay, let's enter a number 4. 16 squared is 1616, okay? The original value was not preserved. So that's really what a pass by reference does. What it does exactly, let's step through this. Okay, what are we passing exactly? Okay, I was hoping to see something else there, but basically what we're doing, it looks like we're passing a 4, but we're actually not. We are passing the address of the original variable. For example, what if I do this? I'm going to just comment out this stuff. Okay, you see what I have here? Ampersand original I. Okay, that is, do you see this? Look at my output here. You have some gobbledygook number that really is of no importance to us, but that is the address of the original I variable. So what we're doing here when we run this program, at this point, a pass by reference, we are not passing the 4 or the 3, even though it looked like it when I stepped through it. What we're actually passing is that gobbledygook number, that FF, 004, whatever we saw there. And it's like saying, hey, square this. Here's my address and the keys to the house. Go in there and do anything you want. Okay, you're just giving the function full access to that original variable location by providing the address to the function. And then the function is going to get in there and change it and tamper with it and overwrite it, and that original value is gone forever. Okay, so that's why you want to be careful with a pass-by reference. Really, all you really need to know, unless you're very serious about continuing programming, all you need to know is a pass-by reference. You'll see the ampersand, And it really is passing the address of that original variable. But like I said, you want to be careful with that because you can, overwrite data that you didn't mean to, and then that data is gone. So there's your pass by reference. Look for that ampersand. That's really the only time you see the single ampersand in C++ is when you're referring to the address of a variable. So you can think of this as a pass by address. That might be a better way of thinking about it to remember what's going on here.